So a strange voice from deep space, a mysterious object named the 3-Eye Atlas, has just sent a signal aimed directly at planet Earth.
It began with a flash that no one could explain. For a few seconds, the sun's surface seemed to tremble as a strange blue light drifted across the darkness. Astronomers rushed to their screens, thinking it was a camera glitch, but the signal repeated bright, sharp, and undeniably real. The object responsible was small on the scale of space, yet powerful enough to make Earth's most advanced telescopes question their own readings. They called it 3-Eye Atlas, a visitor from beyond the stars. It wasn't the first interstellar object we had ever seen, but something about it felt different. It moved with precision, glowing stronger as if it knew it was being watched. Each pulse of light seemed almost deliberate, like a heartbeat echoing across the void. At that moment, one question haunted everyone who saw it. If it wasn't a comet, then what exactly had entered our sky? When scientists first tracked the object, they realized it wasn't born here. Its path cut across the solar system from a direction no comet should come from, slicing through the void like a traveler who had crossed unimaginable distances. The Minor Planet Center soon confirmed that this was only the third interstellar object ever recorded, following Oumuamua in 2017 and Borisov in 2019. But this one, they said, was far larger and faster than anything before it. 3-Eye Atlas measured nearly 4 to 7 kilometers wide, big enough to swallow a small mountain. It moved at 22 miles per second, faster than any natural comet of its size ever seen. In simple terms, if Oumuamua was a ping-pong ball, Atlas was a skyscraper moving through space with unstoppable force. Its arrival sent waves of excitement through every observatory on Earth, and a global campaign began to track it day and night. At first, astronomers expected a normal show of a tail of dust, a little ice melting under the sun. Yet the closer it came, the stranger it behaved. Its glow didn't fade as comets usually do. Instead, it pulsed with a cold blue light, almost rhythmic, almost alive. Some said it was reacting to the sun. Others whispered it was responding to us. By late October 2025, as Atlas curved around the sun, one thing became clear. This was no ordinary visitor, and what happened next would challenge everything we thought we knew about space itself. It started with a number that didn't fit. When astronomers at the Alma Observatory in Chile compared the newest data from 3-Eye Atlas to the predicted orbital path, they saw a difference so small it almost looked like a rounding error. Yet in astronomy, a fraction of an arcsecond can rewrite everything. Atlas was not where gravity said it should be. The object had drifted several miles off course, and that deflection could not be explained by any natural force known to science. At first, the team suspected human error. They checked the antenna positions, verified the timing, and recalibrated every piece of equipment. Nothing was wrong. The offset was real. Over the next week, independent teams at Gemini South and the European Southern Observatory confirmed the same reading. It was as if an invisible hand had nudged the object sideways, quietly but with purpose. For scientists who live by numbers, this was like finding a heartbeat in a machine that should be dead. In physics, motion is law. Every body moves according to predictable forces: gravity, radiation, momentum. But Atlas broke those rules. It was being accelerated by something else, something unseen.
Visitor, that comet or question mark 3-Eye Atlas?
Astronomers called it non-gravitational acceleration, a term usually reserved for comets that vent gas or ice as they heat up. But Atlas was different. The amount of force needed to shift its trajectory implied a massive outflow of material, yet not a single trace of debris was detected. No dust, no jets, not even a wisp of vapor. It was moving on its own, and that thought unsettled even the most skeptical minds. The more they analyzed, the stranger it became. ALMA's data was reprocessed through multiple programs to remove distortion and test for software errors. Each time, the same result appeared, a 4 arcsecond deviation. To put that into perspective, it was the difference between a bullet hitting its target and landing a mile away. The accuracy of ALMA's instruments made this even more impossible. Under normal conditions, its margin of error is less than half an arcsecond. Something powerful was interfering, and no one could agree on what it was. Some scientists suggested that Atlas might be venting superheated carbon gases, invisible in standard wavelengths. Others thought it could be responding to solar radiation in a way no comet ever had. A few dared to ask the question no one wanted to say out loud: what if the force wasn't natural at all? What if the object was being guided? Those words echoed through research rooms late into the night. Every time someone proposed a theory, the numbers refused to cooperate. Meanwhile, telescopes across the world turned their focus toward the mysterious visitor. NASA's Solar and Heliospheric Observatory captured a faint shimmer in its tail, but it wasn't behaving like ice. It looked more metallic, almost reflective. The pattern of light suggested rotation, slow and deliberate. Spectral analysis from Hubble confirmed the presence of nickel and iron elements rarely dominant in natural comets. These metals are known for strength, for endurance, for building things meant to last. To some, that connection was hard to ignore. By November, the debate had divided the scientific community. Traditional astronomers argued that data was being misinterpreted, that it had to be a coincidence. Others, especially younger researchers, believed the universe had just handed humanity its first real mystery in decades. Online forums and observatory logs filled with theories of magnetic anomalies, dark matter, alien technology. Each explanation only deepened the question. Every night, as 3I Atlas continued its silent journey, more data poured in. Each new observation confirmed the same impossible truth. The object was accelerating without visible cause. For the first time in modern history, the laws of celestial motion were being questioned. It was no longer about a single comet. It was about whether we truly understood how the universe moves. If gravity wasn't pulling it and light wasn't pushing it, then what was? And could that same hidden force still be out there waiting for us to notice it again? When 3I Atlas rounded the sun, astronomers expected the same thing they had seen hundreds of times before: a bright flare, followed by a slow fade. Instead, what they witnessed defied every natural law of comet behavior. The object didn't dim. It exploded in brightness, glowing almost 10 times stronger than before. Within hours, the light curve rose so sharply that it looked less like melting ice and more like an engine igniting. Solar observatories all over the world recorded the event. From NASA's SOHO satellite to Japan's Himawari system, the same data kept repeating: a sudden surge of blue light that peaked far beyond expected levels. The light wasn't just intense, it was strangely pure, carrying wavelengths that made it appear colder than the sun. Scientists described it as a blue flare, though none could explain what caused it. In the language of astronomy, it followed a power law close to r to the -7.5, meaning it brightened 7 times faster than any known comet ever recorded. To understand what was happening, spectroscopic teams from Hubble, ALMA, and the Very Large Telescope turned their sensors toward Atlas. What they found was not what anyone anticipated. The chemical fingerprint revealed a cocktail of gases, carbon compounds, traces of cyanide, and metallic lines belonging to nickel and iron. Normally, a comet's light comes from water vapor and dust scattering sunlight. But this was different. The gas composition of Atlas was so rare that it resembled the spectrum of refined materials, something closer to engineered metal than natural rock. More surprising was what wasn't there. There was almost no water. Typical comets are made up of more than half frozen ice, but Atlas showed less than 4% by mass. It was dry, dense, and oddly reflective. The way it scattered sunlight made it look metallic under certain filters. Its blue glow didn't match thermal emissions or chemical outgassing. Instead, it behaved like light bouncing off polished surfaces. At that point, theories began to split. Some researchers believed Atlas had originated near a dying star, where metals are forged in intense heat. Others argued that it might have been formed in a region of the galaxy far colder than ours, which could explain its dryness and density. But another idea started spreading online that blurred the line between science and speculation. What if the light wasn't caused by the sun at all? What if Atlas was reacting to observation itself? Each night, telescopes continued to monitor the object, and something strange kept happening. Every time a new array focused on it, the light seemed to pulse in irregular intervals, almost like a response. The timing was too coincidental for comfort. Some claimed the glow intensified whenever multiple telescopes locked on simultaneously. Others dismissed it as coincidence, a trick of atmospheric interference or sensor noise. But no one could ignore the feeling that the object was aware of being watched. By late November, the blue light had stabilized, maintaining an intensity that remained far beyond normal solar reflection. Atlas wasn't losing mass at the rate its brightness suggested. That alone broke another rule of comet physics. If it was shedding billions of tons of material, space should have been filled with debris. Yet deep scans showed nothing. The space around it was clean, almost sterile, as though whatever process powered its light left no residue behind. In the simplest terms, 3I Atlas looked alive. It moved with rhythm, glowed with precision, and changed when humans observed it. Every explanation failed to fit, and with each unanswered question, the possibility that it was something built not born began to take shape. If this wasn't sunlight reflecting off dust, then what was really shining inside that blue glow? And could the light itself be trying to tell us something? By the end of November, 3I Atlas had already broken every rule of comet science, but what researchers discovered next pushed the mystery into impossible territory. When the data from different observatories were combined, a clear pattern emerged of 9 separate anomalies that no natural object should ever display together. Each one could be a coincidence, but together they formed something too deliberate, too exact to ignore. The first anomaly was its orbit. Atlas traveled in a retrograde path, meaning it moved opposite to the planets around the Sun, yet it stayed perfectly aligned with the ecliptic plane, the thin disk where most planets orbit. Out of more than 4,000 cataloged comets, less than 10 share this combination. It was as if the object had chosen the most efficient route to pass through our system without colliding with anything. The second anomaly appeared in the photographs of its tail. Unlike every other comet that grows a tail pointing away from the Sun, Atlas had an anti-tail, a jet of light extending toward it. This phenomenon is extremely rare, seen in fewer than 2% of comets, and even then only for short moments. Yet Atlas's sunward jet lasted for weeks, stable and symmetrical, as if it were actively maintaining direction rather than reacting to solar pressure. The third and fourth anomalies were about size and speed. Most comets are small and slow, but Atlas measured between 4 and 7 kilometers across and raced through space at 36 kilometers per second. The odds of finding a natural object that large and that fast coming from interstellar space were less than 1 in 1,000. Even if such a coincidence existed, it shouldn't have survived the trip intact, yet Atlas was whole and undamaged. The fifth anomaly lay within its timing and geometry. Its closest approach to the Sun happened during a rare planetary alignment with Mars, Venus, and Jupiter, all in near-synchronous positions. According to orbital simulations, the probability of such a setup is roughly 5 in 100,000. Some astronomers began to whisper that Atlas's arrival had been planned, perfectly timed to slip through the gravitational balance of the inner planets. The sixth anomaly stunned the spectroscopy teams. When they measured the chemical composition, they found that the nickel-to-iron ratio was unlike anything natural closer to the alloys used in engineered structures. These metals are forged under extreme conditions, and their proportions in Atlas were beyond anything seen in solar system samples. For some, it hinted at construction, not creation. The seventh anomaly was its water content or lack of it. Where ordinary comets are rich in ice, Atlas was almost completely dry. Less than 4% of its mass contained water, making it one of the driest comets ever measured. That dryness meant its glow wasn't powered by sublimation, the usual process that causes comets to shine. The light was coming from something else entirely. Then came the eighth anomaly, discovered by accident. A researcher cross-referencing its entry path noticed it matched, almost perfectly, the sky coordinates of the 1977 WOW signal, the mysterious radio burst once thought to come from outside Earth. The similarity was within 1% of possible trajectories. Coincidence or not, it was enough to make scientists uneasy. Finally, the ninth anomaly, the one no one could deny. After passing the Sun, Atlas's light shifted sharply blue, far more than any comet in history. This change wasn't gradual, it happened in a single day, almost like a switch being flipped. Blue shifted light can mean higher energy, faster motion, or even artificial emissions. Whatever it was, it pushed the object into the realm of the impossible. Each anomaly alone might have been dismissed as bad luck or data error, but all nine, together, created a pattern of purpose. They lined up like clues pointing toward a single truth that Atlas wasn't just wandering, it was moving with intent. And if intent exists, then so does design. Could these 9 impossibilities really belong to a natural comet, or were they the fingerprints of something that wanted to be found? As soon as the list of 9 anomalies reached the scientific community, the reaction was immediate and divided. Some scientists demanded further investigation, while others urged caution, fearing the data had been misread. But behind closed doors, something far stranger began to unfold. Observatories that had freely shared their findings suddenly went quiet. Research portals were locked, and public data archives were taken offline for calibration. To the outside world, it looked like a routine review, but to those inside, it felt like a blackout. At ALMA, the observatory that first detected Atlas's off-course drift, engineers were ordered to recheck every signal from scratch. The process was called an internal audit, but the level of secrecy was unusual. Access to the raw data was restricted to only a handful of senior astronomers. Many younger researchers who had worked on the original discovery were told not to comment publicly. It was as if someone wanted to make sure the world didn't see too much, too soon. Meanwhile, NASA and the European Space Agency released a short joint statement saying that anomalous readings are under review. But what stood out wasn't what they said, it was what they didn't. No new images were published, no updated coordinates were released, and no telescope schedules were confirmed. Even citizen astronomers who tried to track Atlas from their own observatories found themselves cut off from official star catalogs. The object that had once been the most studied in the sky was suddenly invisible on paper. Rumors began to spread. Some said the agencies had detected a signal but didn't know how to interpret it. Others claimed that the blue light had been found to pulse in mathematical patterns, resembling coded transmissions. None of it could be verified, but the speculation grew louder each day. The phrase "data lockdown" started trending across scientific forums, and former NASA employees hinted that the agency had invoked an internal planetary security clause, used only in extreme cases when an observation might cause public panic. The silence was almost as telling as the discoveries themselves. When reporters asked about the missing data, officials simply replied that peer review takes time. Yet peer review had never before required shutting down public access or disabling telescope streams. The scientific method is built on transparency, and the absence of it made even cautious observers suspicious. If nothing unusual was happening, why the sudden wall of secrecy? Inside the astronomy community, tensions rose. Some scientists continued their independent research, releasing their findings anonymously under pseudonyms. One leaked document described persistent anomalies in Atlas's light curve, subtle fluctuations repeating at intervals too regular to be random. Another leak suggested that a few observatories in Asia had detected faint electromagnetic bursts synchronized with those light pulses. If true, it meant the object wasn't just reflecting light, it was emitting something. As the blackout stretched into weeks, the atmosphere grew heavy with fear and fascination. People wanted answers, but the experts who once spoke freely now hesitated. No one wanted to be the first to confirm the unthinkable, that Atlas might not be a comet at all. The debate shifted from "what is it?" to "who gets to decide what we know?" The mystery had escaped the telescope and entered the realm of politics and control. By early December, even the most skeptical voices had gone quiet. Every major space agency promised a full update before Atlas's closest approach to Earth on December 19th, but none delivered. Instead, their websites repeated the same sentence: "Further analysis in progress." The world was left watching the sky, waiting for someone to speak. Because if silence could spread faster than light, what was it hiding this time? December 19th, 2025. The night the world had been waiting for finally arrived. After months of silence and speculation, 3I Atlas was about to pass its closest point to Earth, 1.88 astronomical units away, far enough to be safe but close enough for every telescope to lock on. For scientists, this was the moment of truth. Every unanswered question, every hidden file, would now meet the test of light. Observatories from Hawaii to Chile to the Canary Islands prepared in synchronized precision. At exactly 200 hours, UTC, ALMA began its high-resolution scan, while Hubble and the Very Large Telescope switched to infrared mode to capture the faintest traces of debris. NASA's Deep Space Network coordinated with the European Space Agency and the Indian Space Research Organization to record any radio emissions. If Atlas's acceleration was caused by natural outgassing, then the missing debris, billions of tons of it, should finally appear in the images. But as the first sets of data came in, the screens remained dark. No dust, no ice, no scattering trails that could explain its motion. The region around Atlas was pristine, empty, and silent. For a comet this active, that was impossible. Scientists double-checked their filters, recalibrated their lenses, and extended exposure times. Still nothing. The object glowed bright blue, but its surroundings were cleaner than the space between stars. It was as if it had erased its own footprints. Then something even stranger happened. As multiple observatories began scanning at once, Atlas's brightness suddenly pulsed. It wasn't random. The light flickered in exact intervals, each pulse separated by precisely 19 seconds. The rhythm repeated 5 times before fading back to normal. The data matched across all instruments. ALMA, Hubble, and Gemini South saw the same pattern. It couldn't be a coincidence. In engineering, repetition means control, and that single word changed everything. Around the world, scientists stayed awake through the night, cross-checking the data. Some believed the pulses were caused by rotation, others by reflection from a metallic surface. But the timing was too perfect, too measured. A natural object can spin, but it doesn't signal. When an independent observatory in South Africa confirmed the same 19-second rhythm hours later, the global feed exploded. The word communication began to appear in research notes cautiously, quietly, but undeniably. Meanwhile, the color of the light began to shift. Atlas's blue spectrum grew sharper, almost electric, while faint ultraviolet rays appeared around its edges. That shouldn't have been possible at its distance from the sun. The light was acting like it was being powered from within. Photometric readings suggested bursts of energy equivalent to hundreds of nuclear reactors, yet with no visible exhaust or heat signature. Whatever was happening, it was contained, efficient, and intentional. By sunrise, the world's media had caught on. Live streams showed telescopes tracking the glowing dot, commentators speculating whether this was proof of alien design, but the scientists stayed cautious. They called for verification, for peer review, for patience. The public, however, had already made up its mind. To millions watching, the 19-second pulse was the first handshake between two civilizations. As the day ended, the light began to fade, dimming slowly until it was no longer visible to the naked eye. Atlas continued its path into the dark, untouched, unchanged, leaving behind no dust and no answers. Only silence, the same silence that had followed every discovery since this began. The official statement came 24 hours later. NASA confirmed that no debris had been detected and no signals were identified. But those who saw the data knew better. They had witnessed a pattern too precise to be chance. Something out there had moved, responded, and then disappeared just as if it had finished its task. If Atlas wasn't reacting to gravity or sunlight, then what was it responding to? And more importantly, what did it mean when the universe finally answered back? 3i Atlas entered our skies as a mystery and left as a question that no one could answer. It didn't crash, fade, or vanish. It simply moved on, leaving behind a trail of silence deeper than space itself. Every telescope, every lab, every observer now shares the same uncertainty. What if we just witnessed the first sign of something greater watching us? The universe didn't speak in words. It spoke in light, in rhythm, in design. And maybe, just maybe, it's waiting for us to reply. What do you think 3i Atlas really was?